Hello. All right. Hello, YouTube. Oh my goodness, look at this hair. Ooh, I got this hair sticking up. I am not YouTube ready. All right. All right. Ignore that. We're going to switch views and then you won't even notice it. Hey, everybody. Welcome. 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 Look at us. Look at us. This is day 3. This is day 3 of my SAT review. If you are just catching us today, you can head to the archives. Day 1 and day 2 are up there. We talked, day 1, we talked about linear equations, and we talked about how to solve those with the Desmos calculator. So that was cool. And then day 2, we talked about quadratics, and we also saw how you can do a whole bunch of quadratic work in the Desmos calculator. So those two are on the archive on YouTube for everyonelovesmath.com or Everyone Loves Math. Head on over, man. Head on over and check it out. So welcome. I'm Joey. This is my studio, and we do math here. We have a good time. We do math. So here's what I know. I know there's an SAT coming this Saturday. I know it. And we're going to study for it right now. So the theme of today is we're going to talk about some geometry. So we're going to get to that very shortly. Before we do that, quick commercial. Hey, look, it's my website. Look, it's me. I have a website. I'm Joey. Hi. Everyonelovesmath.com. Head on over and check it out. You can actually hire me as your one-on-one online tutor. Let's see. Let me just show you. I can click on this tutoring button. Right? If I click on this tutoring button, I've got tutoring by the hour or half hour, and then I also have some tutoring bundles. The bundles, you save some money, but let's say you wanted to book some tutoring, maybe for tomorrow. I actually have some space open for tomorrow. So I click on 1 hour of tutoring. I'm going to go down here and pick Thursday and check it out. I still have for tomorrow 3 time slots for an hour's worth of tutoring. So you could either pick 5 o'clock, 5:30, or 9 p.m. These are all Eastern time. And just to show you, if you pick 5 o'clock and hit next, look at this. Put in your name, your email, and your credit card information. It's $50 an hour, although my bundles, you save some money. But if you check out on my website, you will automatically get a Zoom link. And you'll also be able to send me any kind of extra information or handouts or homework via email. And I take care of the rest. So yeah, we meet up and wherever you signed up for tutoring, and we do it, man. So that's the tutoring. If you would like to purchase a bundle, so let me just show you this. I've got some bundles right now, 5 session, 10 session, and 20 session, where you can save 5, 10, and 20% over my hourly rate. And I'm going to drop it in YouTube chat, but if you use the code return of the math at checkout, then you're going to receive an extra 10% on top of all of this. All right. So that's how you can book me for some private tutoring. For today, we're going to kick back and we're going to do some geometry. So this is part of my week of free SAT study sessions. Like I said, we talked mostly about the calculator the last couple days. Today is going to be less calculator because we're going to do some geometry. And then tomorrow we're going to hit up some of the word problems that you're going to come across on the SAT. All right, in 4 hours and 4 sessions, we can't cover everything, but darn it, we can cover this much. All right. So again, what's up? I'm Joey. SAT coming this Saturday. We're going to do some geometry. Let's do it. Before we get to a question, the one thing I want to show you, which nobody ever checks unless we specifically review, is geometry is actually where a large part of the reference sheet is focused on. So it's helpful for you to go and look and see what's on the reference sheet for the SAT. So check me out, man. Do you have to memorize the area or circumference of a circle? No. Right? Area of a rectangle, area of a triangle. Pythagorean theorem. All of these we're going to talk about today. The special right triangles we will not have time to discuss today, and that's better one-on-one. All right, what else besides that? Down here are volumes. Volume of a, what do they call that? Rectangular prism, also known as a shoebox. volume of a cylinder, a sphere, a cone, and a pyramid. The other thing they tell you is the number of degrees in a circle is 360, which, we know. The second one you might not know. The number of radians is 2 pi. So radians is something that you would know if you're in like pre-calculus. That's a different way to measure angles. We're not going to cover that tonight. And then the last one, the sum of the measures in degrees of the angles of a triangle is 180. All right, so the theme of the geometry on the SAT is actually really good news for you. So there are a ton of formulas on the reference sheet. There isn't really much vocabulary at all on this geometry thing. So like when we're looking at these problems, you're not going to be asked the names of things. So like for example, vertical angles, right? We're going to talk about vertical angles today. I'll show you what they are, but you will never be asked on the SAT, are these they won't use the language vertical angles. Because the SAT has to work for like everybody across the globe, basically, and not everybody calls them vertical angles. They still have the same relationship, though, and we'll talk about that in a second. So if we need to come back to this reference sheet, we most absolutely will come back to this reference sheet. Okay, that having been said, let's dig into some problems. So I still have, and of course all my buttons broke. All my buttons broke. But I still have Desmos up here. So if we need a calculator, we can come back to it. But for right now, we're going to stick in geometry land. This is probably where we're going to use a lot of scratch paper. Okay, so let's come on across to it. So let's get started. So question number 18. Triangle XYZ is similar to triangle RST. So let me stop there. The SAT is obsessed with similarity. So let's draw two triangles. All right, so XYZ. I'll just XYZ, sure. And then a similar triangle would have like the same, it would have the same shape, right? It would have the same proportions. The only difference is that it's either going to be, it's either going to be like bigger or smaller, right? Proportionally bigger or smaller. So let's look. So here's triangle XYZ, and then it says it's similar to RST, such that X, Y, and Z correspond to R, S, and T respectively. So when they say respectively, they mean X is the first guy of XYZ, so R needs to be in the same place because he's the first guy of RST. Okay, so now let's take a look here. What else do they tell us? The measure of angle Z is 20 degrees. All right, so I'm going to label that measure of angle Z 20 degrees. Boom, right there. All right, and what else do they say? They say 2xy equals RS. All right, so what that means is, let me just tell you what that means. That means this distance here, xy, let me get a darker highlighter. This distance here, xy, times 2 is this distance here, right? So this is one of those rare cases on the SAT where they actually give you more information than you need. We don't actually need this piece of information, 2xy equals RS. They've already told us that these two triangles are similar, so we know that one of them is, maybe twice the size of the other or 5 times the size of the other. This just cements it for us that the lengths of RS and T are twice the lengths of X, Y, and Z. The reason why I say we don't care about it is because in this problem, they don't ask us about lengths. They ask us, what is the measure of angle T? And angle T is right here. So look at our pictures, man. Look at our pictures. XYZ, RST, since these two triangles are similar, what we can jump to right now is we can say that these two angles are congruent. They're the same angles, they're the same proportions. It's just one of these triangles, all the sides are twice as long. So in this problem, if angle Z is 20 degrees, then gosh darn it, angle T is 20 degrees, right? They have the same angles, just the sides of RST are twice as long. There we go, that's what it looks like. All right, moving on. Now, I started with similarity because similarity is one of the SAT's obsessions. The SAT loves to ask about similarity because the SAT loves the if you know questions. So notice that this previous one, we didn't have to do any work. The only work we needed to do was draw the picture so that we knew what lined up with what. But there weren't any calculations. I didn't even open my calculator. And the SAT loves questions like that. If you know, you know. All right, so let's take a look. Right triangles. So now these are right triangles and we see them little squares. All right, PQR and STU are similar, where P corresponds to S. And we see that in the picture, right? P corresponds to S. They're both in the same places. All right, if the measure of angle Q is 18 degrees, so let's label that. All right, so the measure of angle Q is 18 degrees. What is the measure of angle S? Ooh, look at that. All right, so they're asking us this time about two different angles, but yo, I got some good news for you. Just like that previous problem, gosh, I'm gonna have to zoom in. This triangle just got small. All right, so just like that previous problem, if angle Q is 18, then angle T is 18. So I'm gonna put a little 18 right there, and then look at this triangle. It was on the reference sheet, remember? That the angles of a triangle add up to 180. As it turns out, if you know that the angles of a triangle add up to 180, you know how like in geometry there's like a million theorems? You kind of don't need them if you know that the angles of a triangle add up to make 180. Because what are we about to do? I'm going to call this X, right? Because, you know, I have no creativity, so why not? And what we are going to say is we're going to say angle X plus angle 18 plus that 90 degree angle, those have to add up to 180. And so it's our job just to solve for X, right? So we can subtract 90 on both sides. We can subtract 18 on both sides. We'll end up with 72. So the answer to this problem is angle S is 72 degrees. Why is that? Because 72 plus 18 plus 90 is 180. Remember, similarity is an SAT obsession. Okay. You're going to see some similarity later on as well. Okay, remember, similarity is an obsession, and then as far as the million theorems, look at this. Another one that uses what we just said about triangles. It says in triangle RST. Okay, so let me draw RST. I'm going to do such a great job. RST. Okay, the measure of angle R is 63 degrees. Which of the following could be the measure of angle S, right? There we go. We just want to know what that is, right? Okay, so you might feel like you don't have enough information because what happened to angle T? Well, let me tell you, look at these numbers. So we don't even need angle T. Check this out. I want you to look at B, C, and D. All right, take a second and look at B, C, and D. So of B, C, and D, B is the smallest angle, right? What happens if we add 118 and 63? If we add 118 and 63, then you're already more than 180 degrees. And we haven't even counted this third angle yet. So B, C, and D, all of these are too big. Because if you add any of those to 63 degrees, you're already over 180. So the only one that doesn't break is A, right? Because if A, let's put it in here and just double check, right? So if angle S is 116 degrees, then those 116 and 63, that would add up to 179, which would mean angle T could be 1 degree, and then they would add up to 180. Feeling pretty good about that, right? Now, of course, this is not what this triangle would look like, right? Because the angle I drew, this is not 116 degrees. This angle is not 1 degree, but it doesn't matter because we're letting the math do the work, not my crummy picture, right? All right, look at us moving along. What have we? We've answered 3 questions? My goodness. Okay, let's talk about the next SAT obsession. All right, I've got like 6 released SAT questions that all deal with the same topic, which is this parallel lines, right? So in this problem, they tell you that M and N are parallel. So in geometry class, they might even put these little arrows to show that they're parallel, right? If you've been in geometry, I think this is even covered in like 8th grade or 7th grade, but like we love it when we have parallel lines, right? 2 parallel lines, and then a third line that kind of comes in and cuts those parallel lines. Because what that does, if you remember, is it creates like a million vocabulary words, none of which we have to memorize, but it also creates some relationships. So let's talk, okay? Let's actually, what I'm gonna do is I'm gonna zoom in right here. All right, let's just zoom in to this intersection, and we're not even gonna worry about the problem as a whole, okay? Because remember what I said, the vocabulary is not important, but the relationships are. So what can we do? Well, if this angle right here is 26 degrees, that means this angle is 26 degrees. Now, inside of a geometry class, we would call those vertical angles. On the SAT, they don't care. And that's great, one less piece of vocabulary. But you can tell by looking at it that no matter what, those two angles have to be the same. They have to be congruent. The same is true with these two angles. These two angles also have to be congruent. Look at them, they open up exactly the same. Not only do those two angles have to be congruent, but 26 degrees plus one of them needs to be 180. Do you notice how that's half a circle? So what I can do, if I wanted to, like, I don't know, call this x, then I could say something like 26 plus x equals 180. And if I have that, I can subtract 26 on both sides, and I would get x equals, 154, right? 154 degrees. And so let's go ahead and just replace that, right? I'm going to erase that x, and instead let's put 154 degrees. Boom. Now, if you want to check yourself, by the way, add up all four of these numbers. You're going to get 360, right? Because all four of those angles add up to make a complete circle. Okay, so just by having one angle, notice all I needed was this 26, and we were able to find all four angles at this intersection. Now it's time to zoom out, okay? So remember, you hire me as your private tutor, we could talk about this longer, but in this problem, what you need to notice is that this x degrees right here, since the m and n were parallel, this angle here is also 154 degrees. Because the exact same thing is happening right here. This would be 26 degrees and 26 degrees, and this over here is 154. Whenever you have two parallel lines cut by that third line, which we call a transversal, it creates, like, kind of literally parallel universes, right? Where we've got a 154 here in kind of the upper right. Here we got a 154 in the upper right. Everything matches up, right? That's what it means to be corresponding. All right, so zooming all the way out, we can now answer this question. So the value of x must also be 154. And I'm going to tell you, this is an SAT obsession. It was not hard for me to find additional problems that look just like this. In fact, I did this problem with one of my favorite juniors today. So take a look at this picture again. They give you some information. We'll go and read it, but they give you some information about x and y, but look at those two angles. X and y are congruent. Those are opposite from each other. All right, and then z is that corresponding angle down in the corner. So if you look at this problem from 10 feet away, this is the same problem as the previous one. Okay, so now let's read it. It says, in the figure, m and n are parallel. So of course, they have to be parallel in order for all this corresponding stuff to work. Okay, if x equals 6k plus 13 and y equals 8k minus 29, what is the value of z? So nothing in this problem is too difficult. There's just a few steps. So the first step that we have to realize is they're telling us about angle x and angle y because we know that x and y are the same, right? X and y must be congruent. Officially, remember, those are vertical angles, but also the SAT doesn't care about vertical angle. All right, so if x and y are the same, that gives us like an automatic equation because x was 6k plus 13, and and y is 8k minus 29. So if we set x and y equal to each other, and then we substitute in what x and y both stand for, now we're having fun, man. Now we're doing some math. So what needs to happen here? Well, I'm not going to belabor this point because we've already kind of talked about solving equations on previous days, but we need to get all of the variables together. So I'm going to subtract 6k. That's going to get all the variables to the right, and it's going to keep the k's positive. And then in the same step, because I'm interested in saving some time, we're going to add 29 to both sides. That's going to take that minus 29, get rid of it from the left, get rid of it from the right, and we're going to have variables on one side, numbers on the other, and then I think we're going to be able to just look at this and tell the answer. Let's see. All right, so over there, 6k and minus 6k go away. 29 plus 13, that's 42. And over here, 8k take away 6k is 2k, and the 29s cancel. So we get 42 equals 2k. Divide both sides by 2, or just look at it. K is 21. Right, there it is. K is 21. Now here's the part that bums me out, man. Did you see option B down here? Look at that. Option B is 21. Because what they want, these SAT people, what they want you to do is they want you to get so excited that you found an answer that matches that you pick it. But yo, slow your roll. They're not asking us what K is. They're asking us what Z is. So what are we going to have to do? Well, in order to find Z, there it is, we're going to have to find X and Y. And while we thought we did that, we didn't. We just found K. So let's now actually find angle X. Okay? So to do that, I'm going to zoom back in here and let's play. All right, so if K is 21, then we could say that X, remember, was 6 times K plus 13. Remember that? X was 6k plus 13. So now that we know that K is 21, we just have to do 6 times 21 plus 13. And it is after 8 o'clock. My mental math is terrible. And so I'm going to just put it in my calculator, right? So 6 times 21 plus 13 is 139. So we know that X is 139 degrees. That means Y is 139 degrees. And now it's on us to find this angle and this angle. And remember, these two angles are the angles that must make 180 with 139. So let's see, 139 plus 41 degrees would be 180, right? So that has to be that intersection, right? There's our 4 angles where the opposites are congruent, and all 4 angles add up to 360, all right? Now let's look at angle Z. So angle Z, that corresponds to that 41 degrees, doesn't it? It's not 139. 139 would be down here. So let's zoom out, and let's pick 41 as our answer. In this problem, the value of Z is 41 degrees. Moving and grooving. You love moving and grooving. I love moving and grooving. Let's move and groove. Oh my goodness. It's another one. The funny thing about this one is you can even tell in the picture, this is no man's land out here. So let's see. In the figure, M is parallel to N. So once again, these are parallel lines. So I'm going to make my little parallel symbols like we would in a geometry class. I just want to be a good boy. Okay, so M and N are parallel. Line K intersects both lines. Which of the following must be true? And it's asking us to compare X and 145. All right, well, I think we already kind of did this one to death. X is equal to 145, right? Those are vertical angles, X and 145. These must be the same measure. That's it. So you notice that the geometry stuff on the SAT, if you're preparing, what you do is prepare with these released questions and look and see what the SAT obsessions are. And there's not a lot of calculation. That's like SAT isn't about like crazy calculations for most of their problems. They're not about trick questions. They used to be. They used to be about trick questions. When I was your age, they used to be about trick questions, but they're not. SAT is doable, y'all. All right, here we go. Look at us again. They must have run out of variables because now there's M and N again. And they say M and N are parallel and line T intersects both lines, right? What is the value of X? Well, look at X, right? X is this big angle right here. That's got to be the same as this big angle. Those are corresponding. We also see this 33 degrees. So this must also be 33 degrees because those are corresponding. Oh, So what plus 33 is 180? Because x and 33 make 180 when you combine them. Well, look at your answers. The only one that would make sense, 147 plus 33 is 180. And we just answered another problem about a set of parallel lines cut by a transversal. Again, SAT obsessions. The SAT loves these questions. Oh, so much that I found another one. And I did this, I mean, I know I'm kind of beating a dead horse here, but like, seriously, not a lot that needs to be memorized for geometry. Okay, so what are we looking at here? In the figure below, line C intersects parallel lines S and T. All right, so finally they changed the letters, right? We got S and T. They show us this angle is 110 degrees, which means its corresponding angle has to be 110 degrees. So once again, look at us. We're in this situation where we want to add up 110 degrees plus x degrees to get half a circle, right? Those must add up to 180. Well, 110 plus 70 is 180. And so for this problem, you would just type in the answer 70. And I'm going to tell you, you should feel like, I don't know, I would tell you feel really awesome when you get a problem like this right, because not all of the questions, certainly on the SAT, are multiple choice. And so if you get a non-multiple choice question right, that should make you feel extra good, because you weren't going to guess and get 70, right? And the people in your room that don't know how to break this problem down aren't going to just randomly pick 70. So these are really great questions for showing that you know what you're doing. All right, let's move it on. Let's do question number 5. So question number 5 changes, right? I called it question 5. Sorry. This is question 5 from one of the released SATs. Okay, so this question different. First of all, you see an A, B, and a C, and you both see it, and it tells you that this is a right triangle. All right, so I'm not going to give you whiplash and go back to the reference sheet, but the Pythagorean theorem is on the reference sheet. So you don't have to spell Pythagorean theorem correctly. You don't have to memorize what the Pythagorean theorem is. It's on the reference sheet. All you have to know is that you can find it there. And the Pythagorean theorem says a squared plus b squared equals c squared, right? Boom. Now in this problem, they ask you for the value of c. So if they ask us for the value of c, one of the variables, they must give us the other two variables. And sure enough, they do. They tell us a is 4. So instead of a squared, I'm going to write 4 squared. And b is 5. So by putting 4 in for a and 5 in for b, we now have an equation. And this equation has one variable. We can solve this. We can do this. Let's go. 4 squared. Oh, wait a minute. Look at this. I just noticed something. I'm talking about 4 squareds and 5 squareds. Look at these multiple choice. They don't even want us to find c. They say which expression represents the value of c. All right, well, let's back it up. I see 4 squared plus 5 squared, but that is the expression for c squared. If we want to find the expression for just c, then what you and I need to do is we need to square root both sides of this equation. Because square rooting and squaring are opposites. So the square root of c squared, that's just c. And now we've got our expression. C is the square root of 4 squared plus 5 squared. And sure enough, that matches the multiple choice. You better believe it does. All right, so there's our first viewing of the Pythagorean theorem, right? You know it's on with Pythagorean theorem if they're asking you about sides of a right triangle. So if you're making notes for studying, if it's sides of a right triangle, then it's probably going to be the Pythagorean theorem. Okay, next up. So what is the area in square centimeters of a rectangle with length of 34 centimeters and width of 29 centimeters? Okay, so what I'm going to do is let's grab, so I'm not going to grab the entire reference sheet, But what you need to know is that the area of a rectangle, right? Because this is the area of a rectangle. I know you have this memorized, but it's also in the reference sheet. So we might as well just steal it, right? I grabbed it right from, remember what I showed you, right from that reference sheet. I grabbed it. So there we go. What do we now know? We now know that the length is 34 centimeters and the width is 29 centimeters, right? And so all we have to do is apply the formula. The formula, area equals the length times the width. And they already took care of the units for us. We don't have to type in the units on the SAT. All we have to do, they're really just asking us to multiply those two numbers. I can't multiply those numbers in my head. So I'm going to go to my calculator. 34 times 29. The answer is 986. And I'm just gonna remind you, this was a non-multiple choice question. And I get excited when I see non-multiple choice questions, because do you think that a student that has no idea what they're doing is just gonna stumble across 986? No, they're not. All right, here's another one, non-multiple choice, right? This figure shows a right triangle, so you might get excited. You might say Pythagorean theorem. Let's make sure that we answer this question, though. It says, what is the area of the triangle in square inches? All right, so I'm going to go to my reference sheet. I'm grabbing where it gives us the area of a triangle. And there it is. So in the area of a triangle, we know the formula is 1/2 base times height. Except our triangle doesn't look like their triangle, but that's because in our triangle, this side right here straight up is the height. So I'm just going to say h is 3, right? And the base is 5. And so all we have to do is say area equals 1/2 times base, or I guess base is 5. I'll put it in the right order. It doesn't matter, but I'll put it in the right order. Base times height. So that's half of 15, which we could just type in as 7.5 on the SAT, right? 1/2 of 15, 7.5. All right, we're turning and burning, man. We're going. We're going. Look at us with geometry. This stuff is doable. Y'all can do this. They give you a reference sheet. They don't ask for vocabulary. You get a graphing calculator. Let's do it. Okay, next up. A right circular cylinder. All right, well, let's grab the cylinder. They're asking us for the volume of the cylinder. So volume of a cylinder is in here. It's on the reference sheet. So I'm going to grab it and put it right there, right? So the way that these formulas work, you can predict how this is going to work, right? So we've got our formula, pi r squared h, and it comes right from the reference sheet. Notice that this formula has 3 variables. There's a volume, a radius, and a height. Here's how these problems work, and I'm telling you this because they almost all work in exactly the same way. If you're given a formula and there are 3 variables, then the way these problems almost always go is they're going to give you 2 of them and ask you for the 3rd. All right, so let's take a look. In this problem, the thing that they're asking you for is the volume, right? It says, what is the volume? So I'm going to put a question mark on volume. That's what they're giving us. Now I notice that they tell us the height is 6 centimeters. And now I'm looking for radius, but I don't see it, right? Instead, they tell us that the diameter is 22 centimeters. Well, we know from geometry, if the diameter is 22, then the radius is half of that, right? The radius would be 11. And now what we can do, since we're looking for the volume, is now we can just plug those numbers in. So let's look. We've got pi times 11 squared times 6, right? Pi r squared h. All right, so now might be a good time for me to bring over this calculator. I'm going to show you a little something here. All right, and I got to drag it over because my calculator totally broke yesterday and I haven't fixed it yet. Not my calculator, but my button. Desmos never breaks. Desmos will be there for you. Okay, so what do we need to do? We need to do pi times 11 squared times 6. So in Desmos, you can type, and this is on the test too. If you type in the letters P and then I, it immediately turns into a pi. All right. So I'm going to type in this formula exactly as I see it. Let me see. Let me get it so y'all can see it. All right. So there we go. I'm going to type pi times 11 squared. Oops, not 11 to the 23rd. Goodness, 11 squared times 6. Now, if we look at that, we get this answer, right? 2,280 point some stuff. And that's not any of them. And here's the reason why. The reason why this isn't matching is, do you notice the multiple choice all have pi's in them? So what they want us to do is they don't want us to include pi in this multiplication. If we just do 11 squared times 6, that's 726. And so the answer to this problem, we can say, is pi times 726 or 726 pi. So this one, they're just trying to save you from having to round and stuff, right? So there we go. We grabbed the volume formula from the reference sheet. It had 3 variables. We put in numbers for 2 of them and found the third. That's it. All right, here we go. A right triangular prism. We want the volume of it. All right, so on the reference sheet, they don't tell you what these shapes are, right? That's the only thing about the reference sheet. You'll just see a picture and the formula. So you'll need to know that this is a rectangular prism. So a rectangular prism is length times width times height. And so if we look at this, thing, we just need, I'm going to write this out. So here they're giving it to us as a function. So instead of v equals, it's v of x equals. But we're going to do length times width times height, right? That's what we need. So let's go and read the problem now, right? I've done all that and I've barely even read the problem. So what's it say? It says a right rectangular prism has a height of 9 inches. Oh, cool. So let's put 9 in for the height. The length of the prism's base, is x inches. So how about x, right? Which is 7 inches more than the width. So that means the width has to be x minus 7, because the length is 7 more than the width. All right, so there's our multiplication problem. To be honest, this kind of scares me. I would want to put my x minus 7 in parentheses because that whole thing is the width. Now let's look. We have x times x minus 7 times 9. Well, that's exactly the same as option C. All right. Groovy. Groovy, I'm hoping you're enjoying this review. We don't have too much of it left. Let's see. A cube. So let's see, a cube. Now, they don't give us the formula for a cube. But a cube is just a special type of rectangular solid, right? There's a rectangular solid. And a cube is a special type where all three dimensions, length, width, and height, are all the same. So I'm going to draw this. I'm going to let the math do the work here. So a cube has an edge length of 41 inches. Well, that means that not only is the length 41 inches, but so is the width, and so is the height. And I know that this picture doesn't look like a cube, but who cares? The math helps us, right? So what is the volume of this cube? Well, since a cube is just a special type of rectangular prism, length times width times height. We just have to do 41 cubed, right? Because we're talking about a cube. All right, so what happens if we do 41 times itself 3 times? We get 68,921. And that is exactly D. All right, where are we at? Okay, so there are, in this geometry section, there are also some unit conversions where they're asking us to convert. So in this particular problem, they're asking us to convert between square miles and square yards. All right, and so the first thing you have to ask yourself is, all right, it shows us how many yards are in a mile. What you need to do, since we're talking about square yards, notice they underlined it. We're talking about square yards and not yards. So the shortest way to this answer is to write down the conversion. 1 mile is the same as 1,760 yards. And if we want to convert to square yards, then we should square both sides. All right, so 1 mile times 1 mile would be 1 square mile. And this is about to give us the conversion for 1 square mile. 1,760 times itself, I don't know. Let's see, what would that be? That would be 3 million. Oh boy, this is a big one, isn't it? So 1760 times 1760 is 3,097,600. There we go. So that's measured in square yards. Okay. And so now we can use this conversion. So let's see. A certain town has an area of 4.36 square miles. What we want to do is we want to multiply this by a conversion. We want to cancel out 1 square mile in the bottom and be left with square yards on the top. Have you ever done unit conversion like this? With what my geometry teacher used to call funny forms of 1. Because now that we have this conversion, look what's about to happen. The units are the secret. Miles squared, or square miles, and square miles are going to cancel out. The only unit left is going to be square yards. And the math that we have to do is we have to multiply 4.36 times like 3 million. Well, only one of these could even be it. I don't need a calculator to tell me. Answer's going to be D, right? That's the only one that's even over 1 million. And it should make sense, right? 4 times 3-ish million would be like 12-ish million. Use a calculator. You'll get there, man. Okay. So that is what the unit conversions look like when we're talking about square units. I believe, yes, I did give you another one. This one has us convert from square yards to square miles. All right, so let's use that same thing again. If 1 mile is 1,760 yards, and we square both sides, 1 squared is 1, so 1 square mile is 3,097,600 square yards. Now I should, I gotta move that over so you can see it. So I do want to be clear about one thing. Notice you do not have to memorize how many yards are in a mile, right? For both of these problems, they told you that. And the reason why they did is because this is the hard part, right? The hard part is knowing how to go from how to go from miles and yards to square miles and square yards. All right, so now let's set up this conversion. We've got 11,863,808 square yards. I'm going to multiply that by a funny form of 1, where the square yards are going to cancel, and we'll be left with square miles. Well, let's use that conversion. 1 square mile is 3,097,600 square yards. And so just like before, we leave it for the units to cancel. So we're going to be left with square miles, which is what they asked us for. And the calculation we have to do is we have to do this number here divided by this number since it's in the denominator. Right? So once you set up the units, the units tell you what calculations to do. All right, so let's do it. I still got my old problem in here. Let's see. Let me shrink that up and let's do it. 118,63808. I'm sure there's a better way to say that number, right? 11 million and stuff divided by 3,097,600, right? So the 11 million divided by 3-ish million is 3.83. And so looking at this problem, we notice that B matches. We know that we need square miles. We are done. 3.83 square miles. All right, so this was just, let me get back to my camera here. So this was just a little bit of geometry review just to get you in a good place for your test. Remember, tomorrow, same time, same channel, we're going to do word problems at 8. And then if you would like to schedule any time with me before this test, I am bookable at everyonelovesmath.com. So come on by, book some tutoring time with me if you need it. And otherwise, I will catch you tomorrow, Thursday. What is that, August